My dear students, welcome back to our channel. Students, in this video I am explaining MBA first semester. Subject IT Applications for Management. Important long questions and answers. Let's start quick revision. First unit. First important long question is: explain components of computers. A computer is made up of several key components that work together to perform tasks. These components can be divided into two main categories: hardware and software. Here, we'll focus on the hardware components, which are the physical parts of the computer. 1. Central Processing Unit, CPU. The CPU is the brain of the computer. It processes instructions from programs and coordinates the activities of all other hardware components. For example, when you open a program, the CPU works to load and run it. 2. Memory, RAM. RAM, Random Access Memory, is temporary storage that stores data the computer is actively using. It's much faster than the hard drive, allowing programs to run smoothly. For example, if you open a web browser, the browser data is temporarily stored in RAM for quick access. 3. Storage, hard drive or SSD. The hard drive, HDD, or solid-state drive, SSD, is where all data is permanently stored, including your files, programs, and the operating system. An SSD is faster and more reliable than an HDD. For example, when you save a file, it's stored on your hard drive or SSD. 4. Motherboard. The motherboard is the main circuit board that connects all the components of the computer. It allows the CPU, memory, storage, and other parts to communicate with each other. For example, when you press a key on the keyboard, the motherboard sends the signal to the CPU to process the action. 5. Input devices. Input devices allow you to interact with the computer. Examples include the keyboard for typing and the mouse for clicking and scrolling. 6. Output devices. Output devices display the results of the computer's actions. Examples include monitors for showing visuals and printers for printing documents. 7. Power Supply Unit, PSU. The PSU provides the electrical power needed to run the computer. It converts electricity from an outlet into a form that the computer components can use. Conclusion. In short, a computer's components work together to make it function. The CPU processes data, the memory stores temporary data, the storage holds permanent data, the motherboard connects everything, and input-output devices let you interact with the computer. The power supply unit provides the energy to make everything work. All these components are essential for a computer to operate efficiently. Next important long question is: programming languages and their classification. Programming languages are used to give instructions to a computer so that it can perform specific tasks. There are many types of programming languages, each with its own purpose and way of coding. They can be classified in different ways based on their functionality, level of abstraction, or purpose. 1. High-level versus low-level languages. High-level languages, these are closer to human languages and are easier to write, read, and understand. They are abstracted from the hardware, meaning the programmer doesn't need to worry about the computer's internal workings. Examples include Python, Java, and C++. For example, Writing a program to add to numbers in Python looks simple and readable. Example: A is equal to 5. B is equal to 10. Print A plus B. Low-level languages, these are closer to machine language, which the computer understands directly. They offer more control over hardware but are harder to write and understand. The two main low-level languages are assembly language and machine language. An example would be programming directly for a specific microprocessor. Example: in assembly, the code looks like MOV AX 5, MOV BX 10, add AX BX. 2. Procedural versus object-oriented versus functional. Procedural programming, this is based on a sequence of instructions or procedures. The focus is on tasks and functions. C is a classic procedural language. Example: a C program to add numbers involves defining functions and calling them. Object-oriented programming, OP, this type focuses on objects, which represent data and the methods to manipulate that data. Java and C++ are common OP languages. It emphasizes code reuse and organization. Example: functional programming, this focuses on functions and mathematical logic, avoiding changing states or mutable data. Haskell and Lisp are functional programming languages. Example: sum is equal to x, y is equal to x plus y. 3. Scripting versus compiled languages. Scripting languages, these are interpreted and run by an interpreter. Python, JavaScript, and Ruby are examples. These languages are used for automating tasks or creating small programs. Compiled languages, these are converted into machine code by a compiler, making them faster to execute. Examples include C, C++, and Go. Conclusion: in short, programming languages come in different types based on their purpose. High-level languages are easier for humans to understand, while low-level languages give more control over the hardware. Procedural, object-oriented, and functional programming each offer different approaches to solving problems. Additionally, scripting languages are typically used for automation, while compiled languages are used for performance-heavy tasks. The choice of programming language depends on the task at hand and the developer's preference. Next important long question is: role of IT in business. Information technology, IT, plays a crucial role in modern business by improving efficiency, productivity, and communication. It helps companies manage data, interact with customers, and stay competitive in the market. Let's explore how IT contributes to business operations. 1. Improving efficiency. IT helps automate repetitive tasks, saving time and reducing human error. For example, accounting software automatically tracks expenses and generates reports, freeing up employees to focus on more strategic tasks. Enterprise resource planning, ERP, systems integrate various business processes like finance, inventory, and HR, allowing businesses to streamline operations. 2. Enhancing communication. Technology has made it easier for businesses to communicate internally and externally. Email, instant messaging, and video conferencing tools like Zoom or Microsoft Teams allow employees to connect and collaborate from anywhere. For example, remote teams can use these tools to share ideas and solve Problems in real time, improving productivity. 3. Data management and decision making. IT systems help businesses gather and store vast amounts of data. This data can be analyzed to make informed decisions. Customer relationship management, CRM systems, for instance, store customer information and track interactions, allowing businesses to offer personalized services and improve customer satisfaction. Data mining can also help businesses find patterns in sales or customer behavior, guiding marketing strategies. 4. E-commerce and online presence. IT allows businesses to expand their reach through e-commerce platforms. For example, a clothing store can sell products online, reaching customers beyond their local area. Social media platforms also help businesses interact with customers and promote products, building a strong online presence. 5. Security and risk management. IT helps protect business data from cyber threats. With the rise of cybercrime, businesses use firewalls, encryption, and antivirus software to safeguard sensitive information like financial records and customer details. Conclusion. In short, IT is vital for businesses to grow and stay competitive. It enhances efficiency, communication, decision-making, and security. By leveraging technology, businesses can streamline processes, expand their reach, and offer better services to customers. IT has become a backbone for businesses to adapt to the fast-changing market and achieve success. Next important long question is: explain about the opportunities and challenges in IT. Opportunities and challenges in IT are critical aspects that businesses and individuals must consider to fully leverage technology and stay competitive. IT offers numerous benefits, but it also comes with its own set of challenges that need to be managed. Opportunities in IT. 1. Improved efficiency. IT systems automate repetitive tasks, reducing human error and speeding up operations. For example, businesses use enterprise resource planning, ERP, software to integrate various functions like inventory, finance, and HR, making processes smoother and more efficient. 2. Global connectivity. IT has made it easier for businesses to connect with customers and partners worldwide. Online platforms like e-commerce websites and social media enable businesses to reach global audiences, breaking down geographical barriers. 3. Data-driven decision-making. Through data analytics and business intelligence tools, companies can analyze data to make informed decisions. For example, analyzing sales data can help businesses adjust marketing strategies or improve customer service. 4. Innovation and growth. Technology allows businesses to create new products or improve existing ones. For example, companies like Tesla use IT to innovate in electric vehicles and self-driving technology, offering cutting-edge solutions to customers. 5. Flexibility and remote work. Cloud computing and communication tools like Zoom or Microsoft Teams enable employees to work from anywhere, making businesses more flexible and resilient in the face of disruptions like the COVID-19 pandemic. Challenges in IT. 1. Cybersecurity threats. As businesses rely more on IT, the risk of cyber attacks increases. Hacking, phishing, and ransomware attacks can compromise sensitive data. Businesses must invest in strong security measures like firewalls, encryption, and regular security audits. 2. Cost of technology. While IT offers many benefits, implementing new technologies can be expensive. Businesses must balance costs with the potential returns on investment, especially for small companies with limited resources. 3. Technology obsolescence. Technology evolves quickly, and businesses must constantly upgrade systems to stay relevant. Failure to do so can result in a loss of competitiveness as older systems become incompatible or inefficient. 4. Data privacy concerns. As more data is collected, ensuring privacy becomes a significant issue. Companies must comply with regulations like GDPR and protect customer information to build trust and avoid legal problems. 5. Complexity and skills gap. IT systems can be complex, requiring skilled professionals to manage them. There is often a gap between the demand for tech skills and the supply of qualified workers, making it challenging for businesses to find the right talent. Conclusion. In short, IT offers opportunities for increased efficiency, global reach, and innovation, but it also presents challenges like cybersecurity risks, high costs, and the need for constant updates. To succeed, businesses must find a balance between leveraging its benefits and addressing its challenges. Next, second unit. Second unit. First important long question is categories of IS. Information systems, IS, are used by organizations to collect, process, store, and analyze data to support decision-making and operations. There are several categories of information systems, each serving a different purpose. Here's an overview. 1. Transaction Processing System, TPS. A transaction processing system is designed to process and record daily business transactions. These systems handle routine tasks like sales, payroll, or inventory updates. Example, a point of sale, POS, system at a store processes sales transactions. When customers buy items, it tracks inventory, records payments, and updates the store's database. 2. Management Information System, MIS. A management information system is used to analyze data and generate reports that help managers make decisions. It summarizes data from TPS and provides insights like sales reports, employee performance, or inventory levels. Example, a company might use an MIS to generate monthly financial reports for management, helping them track the business's performance and make strategic decisions. 3. Decision Support System, DSS. A decision support system helps managers make decisions by providing data analysis tools and models. DSS can analyze data, predict outcomes, and suggest solutions to complex problems. Example, a DSS might be used in a retail business to analyze sales trends and suggest the best stock levels for the upcoming season based on previous data. 4. Expert System, ES. An expert system mimics the decision-making abilities of a human expert. It uses knowledge bases and inference rules to solve specific problems or provide advice. Example, a medical diagnosis system could help doctors identify diseases based on patient symptoms and medical history, acting as a virtual expert. 5. Executive Information System, EIS. An executive information system provides top-level managers with quick access to key performance indicators, KPIs, and other high-level data. EIS is used to monitor business performance and trends. Example, a CEO may use an EIS dashboard to view company-wide metrics, such as sales, profits, and market share, at a glance to guide strategic decisions. 6. Enterprise Resource Planning (ERP) System. An enterprise resource planning (ERP) system integrates core business functions like finance, HR, and supply chain management into a unified system. It helps streamline operations and improve communication between departments. Example, a company using an ERP system could have its sales, inventory, and accounting departments all accessing the same data in real time, making it easier to track orders and manage resources. Conclusion. In short, information systems are categorized into systems like TPS, MIS, DSS, ES, EIS, and ERP, each serving specific needs such as handling transactions, aiding decision-making, or integrating business functions. These systems help businesses run more efficiently and make better decisions. Next important long question is: explain architecture of DSS. The architecture of a decision support system, DSS, refers to the structure and components that work together to help managers make decisions. A DSS is designed to analyze large amounts of data and provide insights for decision-making. Its architecture typically consists of 5 main components. 1. Data Management Subsystem. This component collects, stores, and manages data from various sources, including internal databases, external data feeds, and real-time information. The Data Management Subsystem ensures that the DSS has access to accurate and up-to-date data for analysis. Example, a retailer's DSS might gather sales data, inventory information, and market trends to help make decisions about product stock levels. 2. Model Management Subsystem. The Model Management Subsystem provides tools and models to analyze the data. These models may include statistical models, forecasting models, or optimization models that help users simulate different scenarios and predict outcomes based on various inputs. Example, a DSS used by a manufacturing company might use models to predict the impact of increasing production or changing the supply chain on costs and profits. 3. User Interface Subsystem. The User Interface Subsystem allows users to interact with the DSS. It provides a user-friendly way to input data, run analysis, and view results. This could be through dashboards, reports, or visual charts that present the information in an easy-to-understand format. Example, a business executive might use an interactive dashboard to view key performance indicators, KPIs, and run what-if scenarios on sales data to make informed decisions. 4. Knowledge Base. The knowledge base stores the expertise, rules, and best practices that can help in making decisions. It can be in the form of rules, heuristics, or domain knowledge that guides the decision-making process. Example, a DSS for a healthcare organization may include guidelines or medical best practices for diagnosing diseases or recommending treatments. 5. Communication Subsystem. This component ensures that the DSS can share information with other systems, such as ERP or CRM systems. It allows users to exchange results, get feedback, and collaborate with other departments or decision makers. Example, a company's DSS might communicate with its ERP system to adjust inventory levels based on sales predictions made using the DSS. Conclusion. In short, the architecture of a decision support system includes the data management subsystem, model management subsystem, user interface subsystem, knowledge base, and communication subsystem. These components work together to help decision makers analyze data, model different scenarios, and make informed decisions. Next important long question is data warehouse and its applications. A data warehouse, DW, is a large, centralized repository that stores data from different sources within an organization. It is designed to facilitate reporting, analysis, and decision-making by organizing and consolidating data from various operational systems. Key characteristics of a data warehouse. 1. Subject-oriented. Data is organized around key subjects such as sales, customers, or products, rather than specific processes or transactions. 2. Integrated. Data from different sources, example, databases, spreadsheets, is standardized and integrated into one consistent format. 3. Non-volatile. Once data is entered into the data warehouse, it remains unchanged. This ensures stable historical data for analysis. 4. Time variant. Data is stored over time, allowing users to analyze trends and changes. Applications of data warehouse. 1. Business intelligence. By data warehouse support business intelligence systems that provide insights through reports, dashboards, and data visualizations. For example, a retail chain can analyze sales data from multiple locations over time to identify trends, customer preferences, or inventory needs. Example, a company might use a data warehouse to combine sales data from different stores and analyze regional performance to determine which products are selling best in specific locations. 2. Decision support. Data warehouse enable decision makers to make informed decisions by providing a comprehensive, historical view of organizational data. These systems allow users to run complex queries and perform what-if analysis. Example, a manager in a manufacturing company might analyze historical production data to determine the best production schedule for a new product launch. 3. Data mining. Data warehouse facilitate data mining, which involves analyzing large sets of data to identify patterns or correlations. For example, a bank might use data mining to identify potential fraudulent transactions by analyzing customer behavior patterns. 4. Customer Relationship Management (CRM). Data warehouse support CRM systems by consolidating customer data across different touchpoints. This enables companies to offer personalized services and improve customer retention. Example, a telecom company might use a data warehouse to consolidate customer service interactions, billing data, and usage patterns, then offer customized promotions to individual customers. Conclusion. In short, a data warehouse is a centralized repository that stores historical and integrated data, supporting various applications like business intelligence, decision support, data mining, and CRM. It helps businesses analyze large volumes of data to make more informed decisions and improve operational efficiency. Next important long question is, Write a note on artificial intelligence. Artificial intelligence, AI, refers to the ability of machines or computers to perform tasks that typically require human intelligence. These tasks include learning, problem-solving, understanding language, and even recognizing patterns. Key concepts of AI. 1. Machine learning. ML machine learning is a subset of AI where computers learn from data and improve their performance over time without being explicitly programmed. For example, an email system can learn to filter spam messages based on previous patterns and user feedback. Example, a movie recommendation system, like the one used by Netflix, suggests movies based on your viewing history and preferences. Over time, it learns to improve recommendations as you watch more content. 2. Natural language processing, NLP. NLP allows computers to understand and respond to human language. It is used in applications like virtual assistants and chatbots, enabling machines to interpret spoken or written language. Example, Siri or Alexa are virtual assistants that use NLP to understand voice commands like "What's the weather today?" and provide a response in natural language. 3. Computer vision. This allows machines to interpret and make decisions based on visual data. It is used in facial recognition, self-driving cars, and image analysis. Example, self-driving cars use computer vision to analyze their environment, such as detecting pedestrians, traffic signs, and other vehicles to navigate safely. 4. Robotics. AI-powered robots can perform physical tasks in various fields, such as manufacturing, healthcare, and even home assistance. These robots can adapt to new situations and improve through learning. Example, robot vacuum cleaners, like Roomba, use AI to map your house and clean it efficiently, avoiding obstacles and changing their cleaning patterns based on room layout. Applications of AI. 1. Healthcare. AI helps doctors diagnose diseases, suggest treatments, and even predict patient outcomes. For example, AI can analyze medical images to detect abnormalities like tumors. 2. Finance. AI is used to detect fraud by analyzing transaction patterns and to make financial decisions, such as stock market predictions. 3. Entertainment. AI personalizes content recommendations on platforms like Netflix and YouTube based on user preferences. Conclusion. In short, artificial intelligence is the technology that allows machines to mimic human intelligence. It has various applications in healthcare, finance, entertainment, and more. By learning from data and improving over time, AI helps solve problems, increase efficiency, and enhance our daily lives. Next important long question is: write a note on cloud computing. Cloud computing refers to the delivery of computing services like storage, processing power, and software over the internet instead of relying on local servers or personal devices. In simple terms, it allows you to access and store data or run applications online without needing heavy hardware. Example, Google Drive and Dropbox are examples of cloud storage services, where you can store files online and access them from any device connected to the internet. Benefits of cloud computing. Cost-effective. Users don't need to buy expensive hardware and only pay for what they use. Scalability. You can increase or decrease your storage and services based on your needs. Accessibility, data and applications can be accessed from anywhere, anytime using the internet. Conclusion: cloud computing allows individuals and businesses to access and store data online, offering flexibility, cost savings and easy access. Write a note on robotics. Robotics is the field of technology focused on designing and building robots. Machines that can perform tasks autonomously or semi-autonomously. Robots are typically equipped with sensors, processors, and actuators to perform specific functions in industries like manufacturing, healthcare, and home automation. Example: a robotic arm in an automotive factory assembles car parts, or robot vacuum cleaners like Roomba clean floors automatically in homes. Applications of robotics. Manufacturing: robots are used in assembly lines to speed up production and reduce human error. Healthcare: robots assist in surgeries with precision, such as the Da Vinci surgical system. Home: robots like robotic vacuum cleaners and assistive robots help with household chores. Conclusion: robotics is the technology that creates machines capable of performing tasks autonomously, improving efficiency and precision in various sectors. Write a note on virtual reality. Virtual reality, VR, is a technology that immerses users in a computer-generated environment where they can interact with the surroundings as though they are physically there. VR uses special equipment like headsets and controllers to create an interactive 3D experience. Example: a VR game like Beat Saber allows users to wear a VR headset and feel like they are inside a virtual world, interacting with objects and playing the game. Applications of VR. Gaming: VR offers immersive experiences for gamers, making them feel like they're inside the game world. Training and education: VR is used for training purposes, like simulating surgery procedures or flying an aircraft in a flight simulator. Entertainment: virtual reality experiences in theme parks and movies provide users with unique, interactive experiences. Conclusion: virtual reality creates immersive digital worlds, offering exciting opportunities in gaming, education, and entertainment by engaging users in new ways. Next, third unit. Third unit. First important long question is: types of networks. Types of networks. A network is a group of devices, like computers, phones, or printers, connected to share data and resources. There are several types of networks, each with different characteristics and uses. 1. Local Area Network, LAN. A local area network, LAN, connects devices within a small geographic area, like a home, office, or school. It allows devices to share resources like printers, files, and internet connections. Example: in an office, all computers are connected to the same network to share documents, access a central printer, and use the internet. 2. Wide Area Network, WAN. A wide area network, WAN, connects devices across a large geographic area, such as cities or even countries. The internet is the most common example of a WAN. Example: a global company with offices in different countries uses a WAN to connect all its branches, enabling employees to access company resources remotely. 3. Metropolitan Area Network, MAN. A metropolitan area network, MAN, is a network that covers a larger area. than a LAN but is smaller than a WAN, typically covering a city or a large campus. Example, a university with multiple campuses in the same city might use a MAN to connect all its buildings and departments within the city. 4. Personal Area Network, PAN. A personal area network, PAN, is a small network used to connect personal devices, such as smartphones, laptops, or tablets, typically within a range of a few meters. Example, using Bluetooth to connect your phone to a wireless speaker or your laptop to a wireless mouse forms a PAN. 5. Storage Area Network, SAN. A storage area network, SAN, is a specialized network that provides access to high-speed data storage devices, usually used in data centers or large businesses to manage data efficiently. Example, a large company might use a SAN to store all its important files in a centralized location, allowing different devices to access the storage remotely. Conclusion. In short, networks come in different types based on their size and scope, LANs for small areas, homes, offices, WANs for large areas, global networks, MANs for cities, PANs for personal devices, and SANs for storing and managing data efficiently. Each network type serves specific needs depending on the size of the area and the purpose of the connection. Next important long question is network topologies. Network topology refers to the arrangement of devices and the connections between them in a network. It determines how data flows, how devices are connected, and the overall performance of the network. There are several common types of network topologies. 1. Bus topology. In a bus topology, all devices are connected to a single central cable called the bus. Data travels along the bus, and each device checks if the data is for it. Example, an old-school network setup where all computers are connected to one central cable. If there is an issue with the cable, the whole network can be affected. 2. Star topology. In star topology, all devices are connected to a central device, such as a switch or hub. This central device acts as a mediator, allowing communication between devices. Example, a home Wi-Fi network where all devices, laptops, phones, smart TVs connect to the router. If one device fails, the others still work, as long as the router is functional. 3. Ring topology. In ring topology, each device is connected to two other devices, forming a closed loop or ring. Data travels in one direction, passing through each device until it reaches the destination. Example, older networks used for industrial control systems, where devices communicate by passing data along the ring until it reaches the right device. 4. Mesh topology. In mesh topology, every device is connected to every other device. This provides multiple paths for data to travel, offering redundancy and fault tolerance. Example, a data center network where multiple servers are connected to ensure there is no single point of failure. If one connection goes down, data can still travel via another path. 5. Hybrid topology. A hybrid topology is a combination of two or more different topologies. It's designed to take advantage of the strengths of each individual topology. Example, a large office network might use a star topology for each floor and a bus topology between floors. Conclusion. In summary, network topologies include bus, star, ring, mesh, and hybrid. Each topology has its advantages and is suited to different needs. Star is easy to manage, bus is cost-effective, mesh offers redundancy, and hybrid combines various topologies to maximize performance and reliability. Next important long question is applications of communications. Applications of communications. Communication technology plays a crucial role in various industries and everyday life. It involves the exchange of information between people or machines over distances. Communication systems include different methods, such as the internet, phones, radio, and satellites, and have wide-ranging applications. 1. Telecommunication. Telecommunication enables voice communication over long distances. It includes mobile phones, landlines, and internet-based communication like VoIP, voice over Internet Protocol. This technology allows people to communicate in real time, regardless of distance. Example, using a mobile phone to make a call to someone across the world is an example of telecommunication. 2. Internet and social media. The Internet allows people to access information, send messages, and share content. Social media platforms like Facebook, Twitter, and Instagram rely on communication technologies to connect people globally, exchange ideas, and build communities. Example, sending a message on WhatsApp or posting a photo on Instagram is an application of communication technology. 3. Broadcasting. Broadcasting refers to the distribution of audio and video content to a large audience via radio, TV, or the Internet. It allows entertainment, news, and educational content to reach millions of people instantly. Example, watching live news on TV or listening to a radio show are examples of broadcasting. 4. Satellite communication. Satellite communication involves sending signals from Earth to satellites in space, which relay the signals back to Earth. It is widely used for TV broadcasting, weather forecasting, military communication, and Internet access in remote areas. Example, using satellite TV to watch channels in rural areas where regular cable services are unavailable. 5. Video conferencing. Video conferencing technology allows people to communicate face-to-face over long distances using webcams and microphones. It is widely used in business meetings, online classes, and remote collaboration. Example, Zoom or Microsoft Teams are popular platforms for video conferencing in workplaces and educational institutions. Conclusion. In summary, communication technologies have broad applications that include telecommunication, internet, social media, broadcasting, satellite communication, and video conferencing. These technologies help connect people globally, improve business operations, provide entertainment, and ensure access to information in real time. Next important long question is discuss the architecture and functioning of Internet. Architecture and functioning of the Internet. The Internet is a global network that connects millions of computers, allowing them to share information. It operates on a set of technologies, protocols, and devices that work together to ensure smooth data exchange across the world. 1. Internet architecture. The architecture of the Internet consists of multiple layers that work together to provide communication services. A. Devices and systems. These are the computers, smartphones, tablets, and other devices used by people to access the internet. They can send or receive data. Example, a smartphone using Wi-Fi to browse the internet. B. Internet Service Providers, ISPs. ISPs are companies that provide users with access to the internet. They connect homes and businesses to the larger internet infrastructure. Example, companies like Comcast or AT&T offer internet connections to homes. C. Routers and switches. These devices are responsible for directing data packets, small chunks of information, between devices over the internet. They ensure that the data reaches the correct destination by finding the best possible route. Example, when you send an email, routers direct the data to its destination by passing through multiple networks. 2. Internet functioning. The functioning of the internet relies on several key protocols that govern how data is transmitted. A. Transmission Control Protocol, TCP. TCP is responsible for breaking large data into smaller packets and ensuring that these packets reach their destination correctly and in order. Example, when you download a file, TCP breaks it into smaller packets and the receiver puts them back together. B. Internet Protocol, IP. IP addresses identify devices on the internet, allowing data to be sent to the right location. Every device connected to the internet has a unique IP address. Example, your device is assigned an IP address like 192.168.1.1, which helps other devices recognize it. C. Domain Name System, DNS. DNS translates human-readable website names, like google.com, into IP addresses, allowing the internet to direct traffic to the correct website. Example, when you type www.example.com in a browser, DNS converts it to an IP address to access the website. Conclusion. In summary, the internet architecture is built on devices, ISPs, routers, and switches, all working together to connect users. The functioning of the internet relies on protocols like TCP, IP, and DNS to transmit data, route it correctly, and ensure devices can communicate. The Internet's layered approach ensures efficient and reliable communication worldwide. Next important long question is: explain about teleconference and web conferencing platforms. Teleconference and web conferencing platforms. Teleconference and web conferencing are tools that enable people to communicate over long distances. They allow individuals or groups to meet and collaborate without being physically present in the same location. 1. Teleconference. A teleconference is a communication tool that allows people in different locations to communicate via audio, typically over the phone or using specialized teleconference systems. It usually involves multiple participants who can talk and hear each other in real time. Example, a business meeting where employees from various branches dial into a shared conference call number to discuss projects or decisions. This is a typical audio-only conference. 2. Web conferencing. Web conferencing is similar to teleconferencing, but it adds visual and interactive elements. In web conferencing, participants can not only communicate via audio but also share their screens, present slides, and see each other through video. This type of conferencing uses the internet and requires a computer or smartphone with a camera and microphone. Example, platforms like Zoom or Microsoft Teams allow users to join virtual meetings where they can present documents, share their screen, or chat with others using video and audio. Popular platforms for web conferencing. Zoom, one of the most popular platforms, offering features like video calls, screen sharing, virtual backgrounds, and chat. Microsoft Teams, used for work collaboration, Teams offers integrated tools for messaging, file sharing, and video meetings. Google Meet, a Google platform for video conferencing that integrates with Google Workspace, offering easy access to meetings. Skype, another popular option for video and voice calls used for both business and personal communication. Benefits of teleconference and web conferencing. Cost-effective, eliminates the need for travel, saving money and time. Convenient, allows people to meet from anywhere in the world with an internet connection or phone. Collaboration, participants can share files, screen presentations, and engage in discussions as if they were in the same room. Conclusion. In summary, teleconference focuses on audio communication between multiple people, while web conferencing adds video, screen sharing, and other features for a more interactive meeting experience. Popular platforms like Zoom, Microsoft Teams, and Google Meet provide easy and effective ways to communicate and collaborate remotely. These technologies offer great convenience and flexibility, making them valuable tools in both professional and personal settings. Next, fourth unit. Fourth unit. First important long question is importance of sales and marketing systems. Importance of sales and marketing systems. Sales and marketing systems are essential tools for businesses to promote their products, connect with customers, and drive sales growth. These systems help companies organize, track, and optimize their efforts in reaching customers and managing relationships. 1. Efficient lead management. Sales and marketing systems help businesses track potential customers, leads, and manage their journey from initial contact to purchase. These systems can automate tasks like follow-ups, ensuring no lead is forgotten and allowing teams to focus on converting leads into sales. Example, a software company uses a customer relationship management (CRM) system to track prospects who have shown interest in their product and sends automated reminders to sales reps to follow up. 2. Targeted marketing campaigns. These systems allow businesses to create personalized and targeted marketing campaigns based on customer data. By analyzing customer behaviors, preferences, and purchase history, businesses can design campaigns that resonate with specific segments, improving engagement and sales. Example, an online clothing store uses customer data to send personalized email offers, like discounts on products similar to previous purchases, leading to more sales. 3. Better customer relationships. Sales and marketing systems help build stronger customer relationships by providing businesses with detailed customer profiles. This information can be used to deliver personalized communication and enhance customer experience, leading to loyalty and repeat business. Example, a retail business uses a CRM system to store information about customer preferences, allowing the business to recommend products that suit individual tastes. 4. Improved performance tracking. With sales and marketing systems, businesses can track the performance of their campaigns, measure return on investment, ROI, and adjust strategies accordingly. This data-driven approach helps businesses make informed decisions. Example, a company using an analytics tool can see which ad campaign brought in the most sales and optimize future campaigns based on that insight. Conclusion. In conclusion, sales and marketing systems are crucial for organizing customer information, creating personalized campaigns, managing leads, and improving customer relationships. These systems help businesses increase sales, optimize their efforts, and make data-driven decisions. By using these tools effectively, businesses can stay competitive and grow in a fast-paced market. Next important long question is: analyze the challenges of implementing IS in the accounting and finance system. Challenges of implementing information systems, IS, in accounting and finance. Implementing information systems, IS, in accounting and finance can bring several advantages like improved efficiency and accuracy. However, there are several challenges that businesses may face during the implementation process. 1. Data security and privacy concerns. One of the biggest challenges is ensuring the security and privacy of sensitive financial data. Accounting and finance systems store confidential information, such as financial statements, tax records, and customer data. Any data breach or unauthorized access can lead to severe consequences. Example, a company faces issues after its accounting software is hacked, leading to the theft of customer billing details and financial reports. 2. High implementation costs. Implementing a new accounting or finance system can be expensive. Costs may include software purchase, hardware upgrades, training for staff, and maintenance. Small businesses, in particular, may struggle with the financial burden. Example, a small business needs to upgrade its accounting software to meet regulatory changes but is unable to afford the high upfront costs of implementation. 3. Resistance to change. Employees who are used to traditional methods of accounting may resist using new software. This resistance can delay the adoption of the system and reduce its effectiveness. Training is essential to help employees adapt to the new tools. Example, accountants at a company refuse to use a new accounting system because they are comfortable with their manual bookkeeping practices. 4. Integration with existing systems. Integrating a new IS into the existing accounting and finance infrastructure can be complicated. The new system must be compatible with legacy systems like older accounting software or databases, and this can cause data migration issues. Example, a company's new accounting software doesn't integrate smoothly with their old inventory management system, leading to discrepancies in financial data. 5. Compliance with regulations. Accounting and finance systems must comply with ever-changing tax laws, accounting standards, and government regulations. Ensuring the new system adheres to these requirements can be challenging, especially in highly regulated industries. Example, a finance department struggles to adapt its accounting software to comply with new International Financial Reporting Standards, IFRS. Conclusion. In summary, the challenges of implementing information systems in accounting and finance include data security, high costs, employee resistance, integration issues, and regulatory compliance. While these challenges can be significant. Addressing them with proper planning, training, and support can lead to smoother implementation and improved operational efficiency. Next important long question is importance of HR systems. Importance of HR systems. Human resource (HR) systems are essential tools that help businesses manage their workforce efficiently. They streamline HR processes such as recruitment, payroll, performance management, and employee data management. These systems improve the overall functioning of the HR department and contribute to better decision-making in organizations. 1. Efficient employee management. HR systems help store and manage employee information in a centralized database. This reduces paperwork, improves accuracy, and ensures quick access to essential data. Example: an HR system stores employee contact information, performance reviews, and training history, allowing managers to quickly access any employee details. 2. Recruitment and onboarding. HR systems automate the recruitment process, from posting job openings to tracking applications and conducting interviews. This makes hiring faster and more organized. Onboarding features ensure new employees can complete paperwork and get acquainted with company policies before starting. Example: a company uses an HR system to post job openings and track candidate applications. New hires can also complete onboarding tasks such as signing contracts and reviewing policies online. 3. Payroll and benefits management. HR systems automate payroll processing, ensuring employees are paid accurately and on time. They also help manage employee benefits like insurance, retirement plans, and paid time off (PTO). Example: an HR system automatically calculates an employee's salary, deductions for taxes, and benefits, saving time and reducing errors. 4. Performance and training management. HR systems help track employee performance and progress. They enable the creation of performance reviews, goal setting, and training programs. This allows managers to identify areas for improvement and create development plans. Example: a manager uses an HR system to evaluate employee performance, set goals for the next quarter, and recommend training programs to improve skills. 5. Legal compliance. HR systems help ensure that a company complies with labor laws and regulations. They help track working hours, overtime, and employee leave to avoid legal issues. Example: an HR system ensures that employee work hours and overtime are accurately tracked to comply with labor laws. Conclusion. In conclusion, HR systems are important for efficient employee management, streamlining recruitment and onboarding, automating payroll, managing performance, and ensuring legal compliance. These systems help businesses reduce administrative workload, improve accuracy, and enhance employee satisfaction. By utilizing HR systems effectively, companies can create a more organized and productive work environment. Next important long question is: explain stages in System Development Life Cycle, SDLC. Stages in System Development Life Cycle, SDLC. The System Development Life Cycle, SDLC, is a structured approach used to develop, maintain, and retire software systems. It consists of several stages that ensure the system meets its goals effectively and efficiently. Below are the key stages of the SDLC. 1. Planning and requirement gathering. In this stage, the project goals, scope, and requirements are defined. The main objective is to understand the needs of the users and stakeholders and establish clear objectives for the system. Example, a company wants a new inventory management system, so they gather requirements like tracking stock levels, generating reports, and integrating with existing software. 2. System design. Once the requirements are clear, the design phase begins. This involves creating blueprints for the system, including system architecture, user interfaces, and data flow diagrams. It defines how the system will work and how it will meet the requirements. Example, a team designs a user-friendly interface for the inventory system, ensuring easy navigation and real-time updates. 3. Development. During the development stage, the actual code for the system is written based on the design. Developers create software features and integrate them into the system. Example, programmers write code to enable inventory tracking and create features like automated restock alerts. 4. Testing. Testing ensures that the system works as intended. This phase includes identifying and fixing bugs, verifying the system's functionality, and ensuring it meets the requirements. Example, quality assurance teams test the inventory system for errors like wrong stock quantities or broken links. 5. Implementation. In this stage, the system is deployed for use. The system is installed on servers, and employees start using it. Training may be provided to ensure smooth adoption. Example, the company installs the inventory management system on all devices and staff members are trained to use the new system. 6. Maintenance. After the system is live, it enters the maintenance phase. This involves monitoring the system, fixing issues, making updates, and improving performance. Example, the company fixes any bugs reported by users, adds new features, and keeps the system updated with the latest technology. Conclusion. In summary, the SDLC involves planning and requirements gathering, system design, development, testing, implementation, and maintenance. Each stage ensures that the system is well-built, functional, and meets the needs of the business and its users. By following this cycle, businesses can create reliable and efficient software systems. Next important long question is: explain in detail about electronic fund transfer, EFT. Electronic fund transfer, EFT. Electronic fund transfer, EFT, is a system that allows the transfer of money between accounts through electronic means rather than using paper-based methods like checks. EFT is a secure and fast way to move money and can be done through various platforms such as banks, ATMs, or online services. How EFT works? EFT involves the movement of money directly between accounts, typically without the need for physical cash. The process involves the following steps. 1. Initiation. A person or business initiates the transaction by requesting a transfer. This can be done through online banking, mobile apps, or ATMs. 2. Authorization. The sender authorizes the transaction usually by entering account details and a PIN, personal identification number, or password. 3. Processing. The electronic system processes the transaction by communicating with the sender's bank and the recipient's bank to ensure funds are available. 4. Transfer. Once authorized, the funds are transferred electronically to the recipient's account. 5. Completion. Both the sender and recipient receive confirmation and the transaction is recorded in their account statements. Types of EFT. 1. Direct deposit. This is one of the most common forms of EFT where an employer deposits an employee's salary directly into their bank account. Example, an employee receives their monthly salary via direct deposit into their bank account rather than getting a paper check. 2. Wire transfers. A wire transfer is used to send money between two banks, usually for large amounts or urgent transactions. Example, a company makes a payment to a supplier overseas using a wire transfer. 3. ATM transfers. ATM machines allow users to transfer funds between their accounts or to other accounts, often with a bank card and PIN. 4. Online payment systems. Services like PayPal or Venmo are used to transfer money electronically between individuals or businesses. Example, a person sends money to a friend for a shared dinner using an online payment system. Advantages of EFT. Convenience. Transfers can be made anytime, anywhere, reducing the need for physical visits to the bank. Speed. EFT allows for faster transfers, especially compared to traditional methods like checks. Security. Electronic systems use encryption and secure protocols to protect sensitive financial information. Conclusion. In conclusion, electronic fund transfer, EFT, is an efficient, secure, and fast way to move money between accounts electronically. With types like direct deposit, wire transfers, and online payment systems, EFT makes transactions easier for businesses and individuals. It eliminates the need for paper checks and provides a convenient, automated way to manage funds. Next, fifth unit. Fifth unit. First important long question is security threats and attacks in business. In today's digital world, businesses face several security threats and attacks that can compromise sensitive data, harm their reputation, and lead to financial loss. These threats often target a company's network, employees, or customers. 1. Malware attacks. Malware is malicious software designed to damage or gain unauthorized access to systems. It includes viruses, worms, and ransomware. Once installed, malware can steal information, delete files, or hold systems hostage. Example, a company's network is infected with ransomware that locks critical data until a ransom is paid. 2. Phishing. Phishing involves sending fraudulent emails or messages that appear to be from trusted sources, such as banks or companies, to trick recipients into revealing personal information like passwords and credit card numbers. Example, employees receive an email that looks like it's from the company's IT department, asking them to log in and reset their passwords. The email is fake, and the attackers steal login credentials. 3. Denial of service, DOS, attacks. In a DOS attack, the attacker overloads a business's website or network with traffic, causing it to crash and become unavailable. This can interrupt operations and damage customer trust. Example, a company's e-commerce site is targeted with a DOS attack, making it inaccessible to customers during a busy shopping period. 4. Insider threats. Insider threats occur when current or former employees misuse their access to company systems or data for malicious purposes. They may leak sensitive information or steal assets. Example, an employee with access to confidential financial data downloads it and sells it to a competitor. 5. SQL injection. SQL injection is a type of cyber attack where attackers insert malicious code into a website's database query. This can give them access to sensitive data such as customer information or financial records. Example, a business's website has a flaw in its search function, allowing attackers to gain access to its customer database through SQL injection. Conclusion. In conclusion, businesses face multiple security threats like malware, phishing, DOS attacks, insider threats, and SQL injections. These attacks can harm operations, cause financial losses, and damage a company's reputation. By adopting strong security measures like encryption, employee training, and regular system updates, businesses can better protect themselves from these risks. Next important long question is: write about security services. Security services. Security services are essential measures put in place to protect business data, networks, and systems from threats such as unauthorized access, cyber attacks, and data breaches. These services help ensure the confidentiality, integrity, and availability of information and systems. 1. Authentication. Authentication verifies the identity of users or systems before granting access. This process ensures that only authorized individuals can access sensitive information. Example, a company requires employees to use usernames and passwords, along with a fingerprint scan, to access their systems, ensuring that only authorized staff can log in. 2. Encryption. Encryption is the process of converting data into a coded format that can only be read by someone with the decryption key. This helps protect data from unauthorized access during transmission or storage. Example, a bank uses encryption to protect customers' financial transactions online. Even if hackers intercept the data, they cannot read it without the decryption key. 3. Firewalls. Firewalls act as barriers between a company's internal network and external networks, such as the Internet. They monitor and filter incoming and outgoing traffic to prevent unauthorized access. Example, a company's firewall blocks suspicious traffic, such as malware or hacking attempts, from entering the network. 4. Intrusion Detection and Prevention Systems, IDPS. IDPS monitor network activity for signs of potential threats or attacks. They can detect and respond to suspicious activities by blocking or alerting security teams. Example, an IDPS system detects unusual behavior, such as multiple failed login attempts, and alerts the security team to investigate potential hacking attempts. 5. Data backup and recovery. Data backup ensures that critical information is regularly copied and stored safely. In case of a security breach or system failure, the data can be restored to minimize disruption. Example, a company backs up its important documents and databases every night. If a cyber attack wipes out the data, the business can restore the backup and continue operations. 6. Antivirus and anti-malware software. These programs are designed to detect and remove malicious software, such as viruses, worms, and spyware that can harm a system or steal data. Example, an employee's computer has antivirus software that scans and removes any malware attempting to infect the system. Conclusion. In conclusion, security services such as authentication, encryption, firewalls, IDPS, data backup, and antivirus software are essential for protecting business systems and data from threats. By implementing these services, businesses can ensure the safety of their information, maintain trust, and avoid costly security breaches. Next important long question is: explain about digital signatures. A digital signature is a cryptographic technique used to verify the authenticity and integrity of digital messages or documents. It acts like a virtual fingerprint, ensuring that the document hasn't been altered and confirming the sender's identity. How it works. 1. Signing process. The sender creates a hash, a unique code, of the message document. This hash is encrypted using the sender's private key, creating the digital signature. 2. Verification. The recipient uses the sender's public key to decrypt the signature and verify the integrity of the message. If the decrypted hash matches the message's hash, the document is valid. Example, when signing an important contract online, a digital signature ensures that the document was not tampered with and that it genuinely came from the intended person. Next important long question is: explain the types of firewalls. A firewall is a security system designed to protect a computer or network from unauthorized access while allowing legitimate communication. Firewalls can be hardware or software-based, and there are different types of firewalls based on how they function. 1. Packet filtering firewall. This type of firewall inspects packets of data traveling over a network. It allows or blocks the traffic based on predefined security rules such as IP addresses, ports, and protocols. Example, a packet filtering firewall might block traffic from an unknown IP address or deny access to a particular port used by malicious software. 2. Stateful inspection firewall. Stateful firewalls track the state of active connections and make decisions based on the context of the traffic, not just individual packets. This allows more detailed control over connections. Example, a stateful inspection firewall allows a connection request and monitors the conversation's state, ensuring that each packet belongs to a valid session. 3. Proxy firewall. A proxy firewall acts as an intermediary between the internal network and external networks. It receives requests from users, processes them, and then sends them to the destination server, hiding the internal network's details. Example, a company uses a proxy firewall to ensure that users access external websites through it, reducing exposure to harmful content. 4. Next Generation Firewall, NGFW. NGFWs combine the features of traditional firewalls with additional functions, such as deep packet inspection, application awareness, and intrusion prevention. Example, an NGFW can detect and block advanced threats like malware or malicious applications that may try to bypass other firewall types. Conclusion. In summary, digital signatures ensure the authenticity and integrity of digital documents, while firewalls play a crucial role in protecting networks by filtering or blocking unauthorized access. Different firewall types, such as packet filtering, stateful inspection, proxy, and next-generation firewalls. Provide varying levels of security depending on the organization's needs. These measures are essential to safeguard data and systems from potential threats. Next important long question is: explain in brief about biometric techniques. Biometric techniques. Biometric techniques are security methods that use an individual's unique physical or behavioral characteristics for identification and authentication. These methods are widely used in modern security systems because they provide a more reliable and secure way to verify identity compared to traditional methods, like passwords or PINs. Types of biometric techniques. 1. Fingerprint recognition. This technique involves scanning and analyzing the unique patterns of ridges and valleys on an individual's fingertips. It's one of the most commonly used biometric methods for access control and mobile devices. Example: smartphones often use fingerprint scanners to unlock the device and authenticate payments. 2. Facial recognition. Facial recognition identifies people based on the unique features of their face, such as the distance between eyes, nose, shape, and overall facial structure. It is used in various security systems, like airport immigration and mobile devices. Example: face unlock features on phones use facial recognition to grant access to the device. 3. Iris recognition. Iris recognition scans the unique patterns in the colored part of the eye, the iris. This method is highly accurate due to the uniqueness of iris patterns, and it's often used in high-security environments. Example: some airports use iris recognition systems for fast and secure passenger identification. 4. Voice recognition. This technique uses an individual's voice patterns, such as pitch, tone, and rhythm, to verify identity. Voice recognition is becoming more common in customer service and mobile applications. Example: virtual assistants like Amazon Alexa or Apple Siri use voice recognition to respond to commands. 5. Hand geometry. This technique measures the shape and size of a person's hand. It's less commonly used but can be effective in environments where users interact with physical access points like doors or terminals. Example: some secure entry points in buildings use hand geometry for access control. Conclusion. In conclusion, biometric techniques like fingerprint, facial recognition, iris recognition, voice recognition, and hand geometry provide strong, reliable security by verifying individuals based on unique biological traits. These methods are more secure than traditional passwords and are used in various applications, like smartphones, airports, and buildings to ensure safety and efficiency. Next important long question is: cyber laws in India. Cyber laws in India are legal regulations designed to protect individuals and businesses from cybercrimes and ensure the safe use of digital technology. These laws address issues related to cybercrime, online transactions, privacy, and intellectual property in the digital world. The primary law governing cyber activities in India is the Information Technology Act 2000, IT Act 2000. Key provisions of the IT Act 2000. 1. Legal recognition of electronic records and signatures. The IT Act gives legal recognition to electronic records and digital signatures, enabling businesses to conduct transactions electronically. Example, electronic contracts and digital signatures used in e-commerce are legally valid in India. 2. Cybercrimes and penalties. The law defines and penalizes various cybercrimes like hacking, identity theft, cyberstalking, and cyberterrorism. These offenses are punishable with fines and imprisonment. Example, hacking a website or stealing data online can lead to imprisonment for up to 3 years and a fine. 3. Data protection and privacy. The IT Act includes provisions for the protection of personal data and ensures that privacy is maintained while handling sensitive information. Example, companies must secure users' personal data and unauthorized use of this data could lead to legal action. 4. Cybersecurity. The IT Act mandates organizations to implement security measures to protect against cyber attacks and safeguard the integrity of data. Example, organizations are required to secure their networks to prevent data breaches and unauthorized access. 5. Regulation of intermediaries. The law also holds intermediaries like internet service providers, social media platforms, and online marketplaces responsible for the content shared by users on their platforms. They must take down illegal content when notified. Example, social media platforms like Facebook or Twitter must remove harmful content such as hate speech or defamatory posts when reported. Conclusion. In conclusion, cyber laws in India, particularly the Information Technology Act 2000, provide legal protection against cybercrimes, promote electronic transactions, and ensure data privacy. These laws help safeguard individuals, businesses, and government agencies from digital threats and ensure a safe online environment. With increasing reliance on technology, these laws are crucial for maintaining security and order in cyberspace. Next important long question is salient features of the IT Act 2000. The Information Technology Act 2000 IT Act is India's primary law dealing with cybercrimes and electronic commerce. It provides legal recognition to electronic documents and signatures, aiming to enhance the growth of e-commerce and ensure cybersecurity. Below are the key features. 1. Legal recognition of electronic documents and signatures. The IT Act grants legal recognition to electronic records and digital signatures, allowing e-commerce transactions and agreements to be valid under the law. Example, an online contract signed digitally has the same legal status as a traditional paper contract. 2. Cybercrimes and offenses. The Act defines various cybercrimes and imposes penalties for them. These include hacking, cyberstalking, identity theft, and cyberterrorism. The law aims to penalize actions that harm individuals, businesses, or national security. Example, a hacker who breaches a company's database can be sentenced to up to 3 years in prison and a fine. 3. Cybersecurity provisions. The IT Act emphasizes protecting computers, networks, and data from cyber attacks. It mandates organizations to implement adequate security practices and protocols to safeguard sensitive information. Example, companies must install firewalls and encryption systems to secure customer data during online transactions. 4. Intermediary liability. The Act makes intermediaries, such as internet service providers, social media platforms, and websites, accountable for content published by users. If illegal content is uploaded, the intermediary must act upon it by removing the content or face penalties. Example, if a user uploads defamatory content on a social media platform, the platform must take it down upon receiving a notice. 5. Adjudication and Cyber Appellate Tribunal. The IT Act establishes mechanisms for adjudication and the Cyber Appellate Tribunal (CAT) to resolve disputes and provide compensation for cybercrimes or violations of the law. Example, if a person's data is misused or they are a victim of a cybercrime, they can file a complaint with the tribunal for redressal. Conclusion. In conclusion, the IT Act 2000 is a crucial law in India that addresses issues related to cybercrimes, electronic contracts, data protection, and cyber security. It provides legal recognition to electronic records and signatures, holds intermediaries accountable, and ensures that individuals and businesses are protected in the digital space. These provisions are essential for fostering a safe and secure online environment.